Hi, everybody. So today is February 5th, and this class is ES 2110 Statics. And today we're going to talk a little bit about continuing where we are on the schedule. Then I'll take any questions you have and work ahead a little bit so that you know what we're talking about. But first, I want to make sure to devote all the time we need to any questions or uncertainties that you have. So far, in this class, we had a homework assignment, which was homework conversion problems, which was due on January 26th. And the next homework assignment, which is over chapter 2 in our textbook, is due today. So it's actually due by midnight tonight, and I'll get those graded right away. But when you open up that link, it will show you all of the homework sets. And I've already talked about this, I know that you know, but you need to make sure that you do all of the problems from the same edition of the textbook. There are several choices for that, but don't mix and match because otherwise you may miss a key concept. And the other thing is, even though there are 6 homework sets, you'll hand them all in together. Okay, so you'll only make a single submission when you submit that into our Moodle page. All right, and now the other piece of the puzzle is on Wednesday of this week, we will have a quiz. And so this is not proctored. It is timed, but it's open book, open notes, maybe not open neighbor. I mean, you could work together, but I don't really care, but I don't have a plan for that. So what I'm really getting at with the quiz is to make sure that you know, I step you through a problem, and of course you have to do the work properly, but also how to do the work so that when you take your exam, you'll be able to get full credit for all of your work. So that's the deal there. So you'll take the quiz here, and then you will submit the work here, just like a homework assignment. Make sure you take it on engineering comp paper, put your name on the top, the title of that set, and so forth. Okay, so then the next thing is when we take a look at the schedule for today, you can see that we should be through videos 8 and 9, and we would begin on, after the quiz, videos 10 and 11. But so if we go down to 8 and 9, come down 7, 8, and I think oops, there it is, statics lecture number 9. We are just right in front. We're still working through chapter 2. So my first question for you is, when we met last Monday, we talked about vector math. We talked about how to, the commutative, the associative properties of vectors, how to add vectors, how to resolve vectors, how to come up with sums of vectors, and how to split vectors into components. Then we talked briefly about IJK notation. What questions do you have for me at this point? Oh, too easy on me. It's gonna be too easy to do things like that. All right. So my question for you then is, when we talk about how we should use a little bit of time together today, we have 2 different choices. We can do some work at the end of chapter 2. I can work out a 3-dimensional problem, for example, or I can start chapter 3. Which would you prefer? Easy to get along with again? Have you guys finished all of your chapter 2 homework? Okay. Okay. So maybe what I'll do is, okay, let me ask you this question specifically. Have you started working with unit vectors, lambda? Yes. And you're familiar, you're good. Okay. just because that seems to be a concept that a lot of people sort of stumble on. So if you're good, then I would.
Three-dimensional.
Good, okay. Yeah, okay. Oh, that's very good. Okay, so basically, that is a very, and I appreciate you saying that because basically three-dimensional reasoning or three-dimensional analysis is very difficult. I've never met a student or a faculty member for whom it is not difficult. So, I just want to be really clear about that. And oddly enough, three-dimensional analysis can be harder for people who are very visual and have really good three-dimensional reasoning skills. Because if somebody really thinks two-dimensionally, they will tend to rely on the math more heavily. And if somebody has really good spatial skills and can see things three-dimensionally pretty simply or pretty automatically, they'll try to fight doing the math and they'll try to do it, you know, with the skill set that they have. And so what ends up happening in a case like that is, in order to analyze 3D stuff, you have to do the math. There's just no other way. I've never met, I mean, I've been teaching this class for a long time, and I've never met anybody who can really do it without going through the math. So it becomes extraordinarily important to do the math. So when we get, I'm gonna take a look at a homework problem maybe, and we'll just see if I can help you set it up. How does that sound? So we have a whole bunch of homework problems set up here. We have 46, 48, 98, 78, 2.9, 2.106. Okay, so we have a whole bunch of stuff that we've worked on. Let me take a look here. Let's take a look at our homework assignment. 106. How about 112? I haven't done that one. Have you guys done 112 yet? You did? Okay. Well, let's just go through it a little bit and make sure. It is. Yes. Yes. Okay. So let's see. 102. I got everything else. I think I worked through a bunch of this stuff, which is a good deal, right? I didn't do 90. I didn't do 272. I've done something from every single homework set. Okay, so let's see. I'll just take a look at 112. And I'm just going to take about 10 minutes. We'll have a short class today, but I'll go ahead and set it up for you, and then you can kind of compare your work and just see if that is how you would set it up, or if you've got it set up properly. All right. So on 2.112, maybe I should do the one from the book, make sure I have the right version here, or the version that you have. So let's do that. Okay, so let's take a look here. Show the screen in just a second. There we go. Okay. I'll go ahead and share this. All right. So here we have a transmission tower right here, held in place by 3 guy wires attached to a pin at A, the top of the tower, and anchored at B, C, and D. If the tension in wire AC is 590 pounds, determine the vertical force P exerted by the tower on pin A. All right, so what this is saying is there's a couple of things that are fundamental to this analysis. One of them is that the transmission tower, when we do a free body diagram, the transmission tower is pushing up on pin A, and the 3 guy wires are pulling down. So if we look at pin A as being the center of the universe, and we look at what is going on with it, we have the vertical force here pushing up. So if we call that the tower force, it's all going to be in the Y direction, isn't it? In other words, the forces always have to be directed along the mechanism that's carrying the force. So that's sort of the principle that we're working with. All right. So going back, let's just do, I'm gonna go ahead and just work. I'll just do one of the forces. Let's see, so this. Okay, let's look at force A to D, or wait, let's see, which one am I given? AC, all right. So did you work out all three forces?
Yeah.
Okay. All right, well, then you're just ahead of the game, so we'll just make sure, we'll just go ahead and do AD as a force vector. When we look at the dimensions, the first thing, when we find the force that's being carried in AD, we know that that is equal to the tension in AD times lambda along AD. So the first thing that we have to do is to determine lambda. So before we can determine lambda, we need to find the directional vector AD, okay? Yes, I will, thank you. How's that? Okay, so the first thing we have to do is to find the direction of the vector AD, okay? So the direction of the vector AD, the first thing is it goes down, up to down. So in other words, we have to make sure that all of our components correspond to the idea of y being negative from A to D, right? I need to look at something here. Just a second, make sure I have the same problem written out here so I don't try to solve something that you're not working with, because that is not helpful to anybody. All right. I think so too, but 20, 18, yeah, we're good. Okay, so I'll go ahead and make this big. All right, here we go. All right, so from A to D in the X direction, the X direction is slanted across the page, and we are going backward into the page 20 feet. So AD is negative 20 feet in the I direction. In the J direction, A to D goes down 100 feet, so it's negative 100 J. And in the Z direction, we are also going back into the page, and the amount by the dimension is 74 feet, so minus 74K. All right. Now, in order to find that unit vector, the next thing we have to do is to find the length of AD, which we do using a three-dimensional version of the theorem of Pythagoras. So we take negative 20 and square it, add to that negative 100 squared, and add to that negative 74 squared. Okay, now, and then take the square root of that, of that sum. Now, the thing to notice here also is whether it's negative or positive. Yes, always is positive, right? So that means that the length of AD, or the way I'm writing it is magnitude of AD, yep, is going to be, yeah. See, you're way ahead of the game. That's good. 20 squared plus 100 squared plus 74 squared equals, and then I need to take the square root of that. Second square root, second answer, 126. And that's what you said. Very good. 126 feet. All right. What that means then is when we find lambda AD, that's equal to the vector AD divided by the length of AD. And since the vector is a vector and the length is a scalar, we just divide each one of those terms. And that will also give us the directional cosines. Anyway, negative 20 feet over 126 I minus 100 over 126 J minus 74 over 126 K. And we can simplify that. You can either write these as simplified fractions, or you can just do the math and divide it out to get a decimal. So 20 divided by 126, lambda AD then is negative 0.159 I. There we go. And in the J direction, we have 100 divided by 126. So that is minus 0.794 J. And then last but not least, 74 divided by 126. And you get 0.587, negative 0.587 K. Now, if you think about this, since each of these are directional cosines, in other words, this is the cosine with the x-axis, or the y-axis and the z-axis of that vector of AD. If you take each one of these numbers, square them, and add them together, that should equal 1. So if you need a check, you can just do that. You don't, I mean, it's not necessary, but sometimes it's just, yeah, just check your work a little bit. It's right. So if you 1.159 square it, add it to 0.794 squared, and add that to 0.587 squared. And you can see that the answer is 1 to, yeah, to within a wee little tiny bit. So there you go. All right. So there's lambda AD. Now, the next thing I would do, I do not know the force, the magnitude, which would be the tension, but I can say at this point that the force in vector AD is equal to the tension in vector AD, which is just a scalar, times lambda, negative 0.159I minus 0.794J minus 0.587K. Or it's more useful when we distribute this TAD through, and we might, in some cases, we might have a value. Here we don't have a value, right? But we could write that as negative TAD, let's do it this way, negative 0.159 TAD I minus 0.794 TADJ minus 0.587 TADK. So you can see another part of this when you work these problems is to stay organized. Yeah. So then at some point, and this is the last point we're going to do today, we would do a summation of vector forces in all directions in order for that to be stable would be 0. Exactly. And then we would say that the force in the stand is purely vertical, and it's going to be pushing upward. So that means that the force in the tower or the antenna is the magnitude of the force, which is what we're looking for in the J direction. So that means that this is only going to figure into the Y directional equation. So we would break this up into summation forces X equals 0, summation forces Y equals 0, and summation forces Z equals 0, right? So then this would be, I mean, the component that would be over here would be minus 0.159 TAD. Yes, exactly. TACX, TABX, exactly, equals 0. There. And then in the Y direction, you're going to have negative 0.794 TAD, and then you'll have TACY, whatever that turns out to be, in TABY, but you're also going to have the force in the antenna. Okay. Or I don't even know what I want to call that, but whatever it is, but it's purely vertical. So it only comes up in the Y. And then those things together add to 0. Then it's going to turn out that this is what you're looking for, right? In the long run. So then you get everything set up, and then you see what sort of falls out. Yes, substitution, elimination, all of that. So all the math at that point. If your calculator solves matrices, or this is actually just an array, it's not really a matrix, but you can solve this using a matrix solution or an array solution routine, but I just always do it by hand because it's more convenient. I don't know what kind of calculate. We don't have a required calculator for this class. So there you go. But yeah, so that's kind of the deal. So it sounds like you're like 92% there. Sounds like you're just ready to start doing the plug and chug. Good. The other thing to remember on this, just before, as we get ready to leave, is when you write your answer, you're going to have, I'm calling it F in the antenna. And you're going to have some value, right? And you might put J, but then make sure that you write the units. So if it's pounds, or let's see, We're in pounds here, I think. Yeah, we're in pounds. So make sure that you include the units to get full credit. All right. So there we go. So, so then, that's kind of the kicker. That's kind of it for this week. And so, like I said, next Monday, we will meet. Pull this up, so it's sharing, I hope, there we go. So next Monday, we'll meet via Zoom only, same time. And in the meantime, we're just barely gonna get started with chapter 3, because today is the homework for chapter 2, Monday is the quiz over or Wednesday is the quiz over chapter 1 and 2. And so then Friday would be right over here, the 9th. So we'll start with videos 10 and 11. And then I'll change this so that it says Zoom only, and this so that it says Zoom only, and we'll move forward from there. All right. All right, guys. Well, thank you very much. I'll stop the recording and I'll look forward to seeing you virtually next week. Also, as always, if you have any questions or problems, do not hesitate to get a hold of me. All right.